Okay, we're going to go ahead and continue with the Honors Pre-Calculus B semester exam review, and we are going to start with number 44. Okay, so number 44 says, write vector and parametric equations of the line that passes through the point 1, 4, and 3, 9. So the general way that I like to do this is the formula, if you will, is the following. It's not really a formula because one thing you have to remember with parametrizations is that there's more than one way to parametrize, in this case, a line. This is the general format that I like to use. Okay, and you can obviously switch around. You can make this x2, y2, switch these around. Okay, but I'm going to say that 1, 4 is x1, y1, and 3, 9 is x2, y2. Okay, so again, there's more than one way to parameterize this line. There's no indicated direction. It just has to go through both of those points. So if I use my formula up there, I have 1, 4 plus some multiple of the subtraction of the 2. So 3 minus 1, 9 minus 4. So this gets me to 1, 4 plus 2t. So I'm kind of doing this in one step here. 2 with a t and then 5 with a t. And lastly, the most condensed version, if you will, is this. Okay, and I did want to make a note about the answer key for number 44. They also have kind of a third way to write it, where it says x minus 1, y minus 4 equals t times 2, 5. Okay, so if you notice here, what they're doing is they're just kind of rearranging it. So this part here, they have here with the t outside, and they kind of took this equation here that I have up here and just left it in terms of x and y and subtracted 1 and 4 from both of those. Okay, but I preferably like to leave it like this. Okay, so there's number 44. Let's go with number 45. Number 45 says, given the points A, which is 2, negative 1, B, which is 0, 4, what is AB, in other words, going from A to B in component form? Okay, so I'm just going to make a note here. This means from A to B. So this does matter because vectors do have a direction. So I'm going from A to B, which means I'm going to take the components of B and subtract them from the components of A. So I'm going to say this is 0 minus 2, so subtracting the exponents, the x components, so 0 minus 2 and 4 minus negative 1. So that'll give me negative 2, 5. Okay, and that is B. So the answer would be B. Okay, so there's number 45. Let's keep going with number 46. Number 46, what is the magnitude and direction to the nearest tenth of a degree of the vector negative 6, 8? So I'm going to start by finding the magnitude of negative 6, 8. So we're assuming that it's coming from the origin. So your x1, y1, if you will, is 0, 0. So really what you're just doing is this. Okay. So your magnitude is 10. So that's your magnitude. And then the direction, what I'm going to use is the tangent inverse formula. Okay. And one thing to note is this will always be a quadrant 1 angle. So I need to adjust it based on the quadrant that it's actually in. Okay, so let's just make a note. This is actually quadrant 2. Okay, so the rule, if you will, is 180 degrees minus theta, where theta is right here. Okay, So I'm going to say tangent inverse of 8 over 6. I make both of them positive. If you put that in the calculator, you get 53.13, which is a quadrant 1 angle, but we are in quadrant 2. So now I do 180 degrees minus 53.13 degrees, which is 126.9 degrees. So there's my direction. Okay. Okay, next we're going to look at number 47, which starts to review some of the rules for adding, subtracting, what have you, vectors. So 47 represents graphically the vector u plus v, so they start out by giving us this as u, and v is here. Okay, so u plus v, I'm going to do it first with the head to tail method. Okay, so if I kind of take v here and slide it up to the end of u, I can get what u plus v is. So here's u, here's v, put them head to tail, and now this guy here is u plus v. Okay. Then it asks us to do it with the parallelogram method. Okay. Which is very similar, actually, as far as how you draw it. So I'm going to say u, v, and then I'm just going to make a parallelogram out of this. And the diagonal through the center is u plus v. So it's just kind of another way to think about it. Okay, so there's number 47. Let's look at number 48, which is kind of a similar thing. Represent the vector u minus v graphically. So this one does not indicate which way you need to do it. I like the head to tail method, so that's how I'm going to do it. So if I have u and v, I have the same vectors. Okay, and I want to represent u minus v, I'm going to go u, make it the same angle, so u, and then if v goes to the right, negative v is going to go to the left. So from here, I'm going to go this way. Here's minus v, here's u. Okay, so this guy here is u minus v. In other words, u plus negative v. That's another way to think about it. Okay, so there's number 48. Let's keep rolling with number 49. 49, given that a is 2, negative 3, b is 6, 5. So a is given as 2, negative 3. Just write these down while I'm saying them. B is 6, 5. C is R, negative 9. First of all, it says find the dot product, A and B, so this should be a very simple problem. So you take the corresponding components, the x's, and multiply, plus the y's and multiply. Okay, even if this was in 3 dimensions, and if it had a z component, the nice thing is the rules, or the process, if you will, still follows. Okay. Okay, so there's your dot product for number 49. Let's look at number 50. Find the measure of the angle between A and B to the nearest tenth of a degree. So this is just using a formula that they give us, and the formula is as follows. So what this says is the angle between A and B is the inverse cosine of A dot B divided by the magnitude of A times the magnitude of B. So the A dot B we actually found in the first part. So this is going to be cosine inverse of negative 3 over, and then the other thing we need to find is the magnitude of A and the magnitude of B. So the magnitude of A is going to be square root of 2 squared plus negative 3 squared, because A was 2 comma negative 3. Magnitude of B will be the square root of 6 squared, plus 5 squared, because B is 6 comma 5. Okay. This will give you square root of 13. This will give you square root of 61. Okay. So you plug this in, and in the end, rounded to the nearest 10th degree is 96.1 degrees. Okay, so there's number 50. Let's look at 51. So 51 is kind of interesting. It says find the value of r such that the vectors a and c are parallel. So let me just write the vectors a and c again. So they kind of leave this first component of c as some arbitrary number r. Okay, and we want to find r so that a and c are parallel. So what I want you to think about is, I'm going to make a little note here. A and c are parallel. Remember, that's the symbol for parallel. If they make the same angle theta from the positive x-axis. Okay, so in other words, if you were to graph this, so 2, -3, so here's a, the vector a, right? If I want to find c, I need c so that it's going in this same direction, because if it's going in the same direction here, even if they're on top of each other, which they would be if they're coming from the origin, they're going to be parallel if they have the same angle coming from the positive x-axis. So if they have the same angle, that means they're going in the same direction, which means they're parallel. So what I really want to find is r such that the theta, if you will, for a and b are the same. Okay. So what I'm going to say here is the angle for a, let's say angle, we'll call it theta 1 for a, okay, is using the same formula we used before, tangent inverse of 3/2. Okay. Again, where I took the absolute value of the y and the x and I divided them and did tangent inverse. Okay, and actually, I don't actually have to complete that, because what I want to realize is, as long as I get this inside part to be 3/2 for, we'll call it theta 2, then if these are clearly the same, then obviously the tangent inverse is going to be the same of that. So angle theta 2 for c is tangent inverse of, we're going to say 9/r. So if you just kind of look at this, if this is 3/2 and this is 9/r, what you really want is you want 3/2 to equal 9/r. So if I kind of do that on the next page, 3/2 equals 9/r. If you cross multiply here, you'll get, oops, 3r equals 18, which means r has to be 6. So that makes sense, because then when you come back here and you'll have tangent inverse of 3/2 for theta 1, which is for a, and then you'll have tangent inverse of 9/6, which becomes 3/2. So these will definitely give you the same thing, which means their angles are the same, which means they are parallel. Okay, so that is number 51. Let's keep going with 52. 52, find the value of r such that the vectors b and c are perpendicular. So let me write down these again. B was 6, 5. C was r, -9. So one thing you want to realize here is two vectors are perpendicular if their dot products are 0. So I want 6, say a dot c, or b dot c, excuse me, is equal to, write that a little clear, b dot c, still got it wrong, c is 6 times r plus 5 times -9. So just pretending like I know what r is. And this has to be 0 if they're perpendicular, okay? So you have 6r minus 45 equals 0, and then you can just solve for r. Okay, so r is, what is that, 7.5. Okay, so there you have up to number 52, and we will continue in the next section.